Okay, today we are taking a look at simplifying expressions with negative exponents. This is a little bit of a continuation of that first goal that we had. So what does a negative exponent mean? A negative exponent can be written with a positive exponent by moving it to the bottom of a fraction. Now, why does this work? What I'd like you to do, let me erase some of this here. Okay, what I'd like you to do is to think about some exponents. So if I have 3 to the third power, that's 3 times 3 times 3, which is 27. If I have 3 to the second power, that's 3 times 3, which is 9. If I have 3 to the first power, that's 3. If I have 3 to the 0 power, that's 1. So what would 3 to the negative 1 mean? In order to understand that, I need to look at how the simplified side is changing. How do I get from 27 to 9? I divide it by 3. 9 to 3, divide by 3. 3 to 1, divide by 3. 1 to, 1 divided by 3 is 1/3. So 3 to the negative 1 is 1/3. 3 to the negative 2. If I divide that by 3, and most of you probably need to do this in your calculator, but 1/3 divided by 3 is 1/9. Let's do it again. Divide by negative 3. That's 1/27. Are you seeing a pattern? Notice 3 to the third and 3 to the negative third both have 27s. 3 to the negative 2 and 3 to the second power both have 9s. The negative exponent just makes it a small number, a fraction. So the rule is, if you have a negative exponent, move it to the bottom of a denominator, and it'll become positive, and put a 1 in the numerator. So for example, 3 to the negative 2 equals 1 over 3 to the positive 2, which can be simplified to 1/9. X to the negative 7th, move to the bottom with a positive and a 1 on top. One more. 2x to the negative 4th. The only thing that has a negative exponent is the x, so only the x moves to the bottom, and the 2 remains in the top. Okay, let's take a look at some more examples. So, to help you understand this in terms of the quotient rule, think, for example, if I have x to the 4th over x to the 6th, I can subtract those exponents, which then gives me x to the negative 2. But I could also think about x to the negative 2 by expanding x to the 4th. X to the 4th is 1, 2, 3, 4 x's. X to the 6th, 1, 2, 3, 4, 5, 6 x's. And if you recall, you can cancel out pairs because x over x is 1. So that leaves me with 1 over x times x, which is simplified to 1 over x squared. This is another way you can think about the meaning of a negative exponent. So what happens if the negative exponent is already in the denominator? Well, basically all you have to do is move it across that special magic line. If it's already in the denominator, move it up to the numerator and make it positive. So that would mean x cubed. Same thing here. I've got a negative in the numerator, so that'll move to the denominator. And I've got a negative in the denominator, that'll move to the numerator. And they will become then positive. So it becomes y to the 4th over x to the 2nd. So here's a quick refresh on all of those power rules we learned up until this point in chapter 5-1. And so what we're going to do now in 5-5 is combine all of those rules and look at some really complicated expressions that we'll be simplifying. So when you are told to simplify, that automatically means your final answer should only have positive exponents. Okay? So as we're going through, keep that in mind. Looking at letter A, the first thing I notice is I can simplify that. I need to multiply them together because it's a power to a power. Now the other thing I notice is that these two can be added together. That gives me x to the 16th. And now if I look at the quotient here, I notice I can subtract these two, which gives me my final answer of x to the 15th. Why don't you try letter B on your own? This starts with a fake distribute. Everything inside those parentheses must receive the exponent. If there's already an exponent, we're going to multiply them together. Now, all of those exponents are negative, so everything's going to switch. This is going to move to the bottom, this is going to move to the bottom, this is going to move to the top. So that gives me y squared over 9 squared x to the 6th. And remember, if you can do the math, you must simplify. Okay, final answer. All bases are different variables, so we're finished. Try these two on your own. Pause the video. So again, we've got a fake distribute. This is 4 to the negative 3, a to the negative 6. Got to get rid of those negative exponents, so it's 1 over 4 cubed, a to the 6th. Let's do that math. 4 times 4 is 16, times 4 is 64. And I'm finished. All positive exponents, all bases are different. Letter D, this is negative. I see I've got some like bases that I can combine here. That's by subtraction. So it gives me 32 over 8. Negative 3 minus negative 5 is really negative. Hold on, let's go back. I see something else we should do first. This right here, 32 over 8. I can kind of separate this into two fractions. Okay. 32 over 8 can be simplified. What is 32 divided by 8? It's negative 4. Okay, so we've dealt with that. Now let's deal with this. Negative 3 minus negative 5. That's negative 3 plus 5, which is a positive 2. Negative 6 minus negative 2, that's negative 6 plus 2. And I'm left with a negative there. So now, final simplification, I've got to deal with that negative exponent. The positive exponents will stay in the numerator, and the negative exponent will move to the denominator. Final answer. So what I'd like you to do for homework then, oh, I forgot we have one more, a super complicated one. This one's a challenge. So distributing that negative 2 to every part, that gives me 3 negative times a negative is a positive, a to the negative 6, b to the negative 2, 3 to the positive 8th, a to the negative 14, b to the positive 6. All right. I can simplify because I have like bases. The 3's I would subtract the exponents. I get negative 4. Negative 6 minus negative 14 gives me 8. And negative 2 minus 6 gives me negative 8. Keep going. Anything with a negative goes into the bottom to become positive. Anything positive stays in the numerator. And final simplification, 3 to the 4th power gives me 81. So I have a to the 8th over 81b to the 8th. I can't do anything more because all my bases are different. Okay, now for your practice. Make sure you show all of your work.